For over 3 decades, the Hubble Space Telescope has transformed our understanding of the universe. It has captured some of the most stunning and scientifically important images of galaxies, nebulae, and planets beyond our solar system. But Hubble's story didn't begin in the 1990s. It started with a visionary idea in the mid-20th century, long before space exploration even seemed possible. Today, we'll take you through Hubble's journey, from its initial conception in the 1940s to its groundbreaking launch in 1990, and to some of its earliest and most significant discoveries by the year 1995. The idea for a space telescope originated in the 1940s, thanks to Lyman Spitzer, an American astrophysicist. At the time, it was nearly impossible for most people to imagine launching anything into space, let alone a telescope capable of changing humanity's understanding of the universe. In 1946, Spitzer published a visionary paper titled Astronomical Advantages of an Extraterrestrial Observatory. In it, he laid out the immense benefits of placing a telescope in orbit. Ground-based telescopes, as advanced as they were for their time, were limited by Earth's atmosphere. Turbulence in the atmosphere causes light to scatter, resulting in blurry images of space objects. Spitzer argued that a telescope placed in space would be free from this distortion, allowing scientists to observe the universe in unprecedented detail. His paper outlined the potential to peer further into space and even look back in time, thanks to the improved resolution that a space-based telescope could offer. While Spitzer's idea sparked the imagination of astronomers, it wasn't until the 1950s that the dream of space exploration became a reality. In 1957, the Soviet Union launched the first artificial satellite, Sputnik 1, igniting the space race between the United States and the Soviet Union. In response, the United States established NASA in 1958, a pivotal moment for the development of space technology. NASA's formation created the opportunity to explore beyond our atmosphere, but the idea of launching a telescope into space was still far from realization. However, as the space race accelerated, so did the dreams of many scientists. By 1969, the National Academy of Sciences published a report entitled Scientific Uses of the Large Space Telescope, formally supporting the development of Spitzer's vision. The project was officially in motion. The 1970s were a decade of intense planning and research for what was now being referred to as the Large Space Telescope, or LST. By 1974, astrophysicists and engineers had formed a working group to begin mapping out the technical and budgetary requirements for the telescope. But building a telescope that could survive in the harsh environment of space while still being delicate enough to capture light from the farthest reaches of the universe was no small task. NASA had to overcome significant engineering challenges. The primary mirror, for example, had to be perfectly shaped to focus light. Grinding began in 1978 on what would be a 2.4-meter, 7.9-foot wide mirror, large enough to capture light from galaxies billions of light years away. To ensure Hubble's long-term success, NASA also designed the telescope to be serviceable by astronauts. This meant that if something went wrong, or if upgrades were needed, astronauts could be sent into space to repair the telescope, extending its life and capabilities. Delays, setbacks, and triumph, the 1980s. Even with years of meticulous planning, the Hubble project faced significant delays. In 1983, the Large Space Telescope was officially renamed the Hubble Space Telescope in honor of astronomer Edwin Hubble, whose groundbreaking work in the 1920s showed that the universe was expanding. But Hubble's launch, originally planned for 1986, was postponed after the tragic loss of the Space Shuttle Challenger. The disaster put the entire shuttle program on hold for 32 months, delaying Hubble's launch until 1990. The mission to finally launch Hubble was assigned to the crew of Space Shuttle Discovery. On April 24, 1990, Discovery blasted off from the Kennedy Space Center in Florida, carrying 5 astronauts and the Hubble Space Telescope. One day later, on April 25th, Hubble was deployed into orbit with its solar panels and antennas extended by the shuttle crew. A rocky start, Hubble's mirror flaw, 1990 to 1993. The triumph of Hubble's launch quickly turned into a major disappointment. In May 1990, Hubble sent back its first images, but they were not as sharp as expected. After an extensive investigation, NASA discovered a flaw in the telescope's primary mirror spherical aberration. The mirror's curvature was off by just 2 microns, a seemingly tiny error, but it caused the telescope's images to appear blurry. This flaw meant that the telescope couldn't reach its full potential, a huge blow to NASA and the scientific community after decades of planning and over $1 billion in investment. But NASA wasn't ready to give up on Hubble. Thanks to its serviceable design, a mission to correct the flaw was planned. In December 1993, a team of astronauts aboard Space Shuttle Endeavour undertook a high-risk mission to repair Hubble. Over the course of 5 spacewalks, they installed corrective optics that functioned like a pair of glasses for the telescope. By early 1994, Hubble was back in business, and this time, its images were sharper than ever. Early discoveries and breakthroughs, 1990 to 1995. Once Hubble's vision was corrected, it began delivering on its promise, making some of the most groundbreaking discoveries in astronomy. One of its first major successes came in August 1990, when Hubble observed the remnants of supernova 1987A. This exploded star, located in the Large Magellanic Cloud, had been a point of interest for astronomers, and Hubble's images provided unprecedented detail of the gaseous rings surrounding the supernova. In 1994, Hubble captured the dramatic collision of Comet Shoemaker-Levy 9 with Jupiter, showing the scars left on the gas giant's atmosphere after the impact. This event provided scientists with new insights into Jupiter's atmosphere and helped refine models of planetary impacts. Hubble didn't stop there. One of its most important contributions during this time was helping to refine the age of the universe. By measuring the rate at which galaxies are moving away from each other, Hubble was able to provide a more accurate estimate of the Hubble constant, a number that defines the expansion rate of the universe. This, in turn, helped astronomers estimate the age of the universe to be around 13.8 billion years. The legacy of Hubble, 1995 and beyond. By 1995, Hubble had firmly established itself as one of humanity's most important scientific instruments. Its contributions to our understanding of the universe were already profound. But one of Hubble's most iconic achievements came later that same year, the Hubble Deep Field image. For 10 consecutive days in December 1995, Hubble focused on a tiny, seemingly empty patch of sky, no larger than a grain of sand held at arm's length. What it revealed was astonishing: thousands of galaxies, each containing billions of stars. This single image showed the vastness of the universe in a way that had never been seen before. Hubble's discoveries have continued to shape the fields of astronomy and cosmology. Its ability to peer back in time, to capture the light from distant galaxies billions of years old, has given scientists a window into the early universe. But Hubble's impact extends beyond science. Its breathtaking images of the cosmos have inspired people around the world, offering a glimpse into the wonders of the universe. The future of exploration. Although newer telescopes like the James Webb Space Telescope may one day take center stage, Hubble's legacy is irreplaceable. It has not only revolutionized our understanding of the cosmos, but also demonstrated what humanity can achieve through curiosity, perseverance, and technology. As Hubble continues its journey in orbit, it reminds us that exploration is limitless, and there is always more to discover. Thank you for watching. Be sure to subscribe for more videos on the mysteries of the universe and the technology that helps us explore it.